Number 17, we're asked to find all the solutions of the polynomial equation y equals x to the fifth minus x to the fourth minus x to the third minus 7x squared minus 20x minus 12. Now, the degree of this polynomial, meaning the largest exponent, is 5, which means that there's going to be 5 total zeros in this function. That doesn't mean that they'll all be real, but it is going to have 5 zeros, and we have to find all 5 zeros to answer this question. And we're given, with this question, we're given this graph. And the reason that we're given this graph is so that we can easily spot the 3 real zeros. We can see that this comes up and touches the graph at x equals -1, and then goes back in the other direction, and then it crosses at -3, which means that there's going to be a double zero here at -1, and there's going to be a 0 at -3. So we're essentially, by having this graph, we're essentially being given 3 of the 5 zeros for this function. They're going to be -1, -1, and 3. And so what we need to do now is find the 2 complex zeros, the two imaginary zeros of this function. All right. So what we're going to do is divide out those 3 factors that are going to that we know we have, because if x equals -1, then we know one of the factors is going to be x plus 1, and another factor is going to be x plus 1, because those are going to give us our 2 zeros of -1 and -1. And then the other factor is going to be x minus 3, because that's going to give us a 0 of x equals 3. So let's divide all of these things out and then see what we're left with at the end, and then we'll be able to solve for those last 2 zeros. And we're going to do this with synthetic division. So we're going to put in all of our coefficients here. So we have 1, -1, -1, -7, -20, and -12. And then we're going to put one of our zeros out front here. That's going to be -1. Let's start with -1. And let's divide that out. Remember, what we're really doing is dividing by x plus 1. But if we just put our 0 out here, that's going to give us what we need. So let's drop this 1 down. -1 times 1 is -1. Add those together, that gives us -2. -1 times -2 is +2. -1 plus 2 is 1. -1 times 1 is -1. -7 plus -1 is -8. -1 times -8 is +8. -12 plus 8 is -12, or sorry, -20 plus 8 is -12. -1 times -12 is +12. -12 plus 12 is 0. And that's what we wanted, is a remainder of 0. Now let's divide this by our next 0, -1. All right, so then to get our next 0, we're going to divide by x plus 1 again. Drop down this 1. -1 times 1 is -1. -2 plus -1 is -3. -1 times -3 is +3. 1 plus 3 is 4. -1 times 4 is -4. -8 plus -4 is -12. -1 times -12 is +12. -12 plus 12 is 0. And so we have a remainder of 0 again. Now let's divide out our third factor, which is x minus 3. So we're going to put a +3 out front here. That's our third real 0. -1, -1, and 3 were our 3 real zeros. So drop down the 1. 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. 4 plus 0 is 4. And then 3 times 4 is 12. -12 plus 12 is 0. And that's our remainder here. So what we're left with is x squared plus 0x plus 4. And so to find our last two zeros, we're going to take this x squared plus 4, and we're going to set that equal to 0, and then solve for x. So let's subtract 4 from both sides. We get x squared equals negative 4. Now we can take the square root of both sides. Square root of x squared is x, and the square root of negative 4 is going to be 2i. Remember that I is the square root of negative 1. And let's not forget plus or minus. Whenever we take the square root of something, we always want to remember plus or minus. And so our 4 zeros were the 3 real zeros that we found from our graph. X equals negative 1 again, because we had a double 0 there, 3, 2i, and then negative 2i. And that is going to be answer D for number 17.